fashioning models from fashion models. And really, it's a study of color from the most visible fashion events. I picked this project largely because I didn't really know anything about fashion. I'm an electrical engineer by training, spend a lot of time deep into technology, and I'm trying to make a career transition. So showing that I can learn something and gain some intuition about something that I had no exposure to, and provide value there is why I chose this project. So fashion's it's a $3 trillion a year industry that affects all of us, right? And we all participate in it. The trends of the clothes you wear are set by a fashion elite, and people just other designers tend to follow suit, and so being able to identify that these trends can be valuable for retail, a company like Nordstrom, for example, or Target, to identify on kind of what they want to buy next. Fast fashion, there's actually no copyright laws in fashion. So I can make a jacket and then someone else can copy the jacket and you can't sue me, which is very interesting because there's so many different combinations of materials and colors and design processes that making the same jacket is actually not illegal. So a company like H&M, which goes from concept to shelf in 3 weeks, a quick, being able to figure out what to design next is very important. And then, maybe some intuition of saying other designers who follows who. So I started about, you act like it does not affect you. So I had actually, if I take a look at my notes, and I just want to make one more time that my audio is on mute. Okay, good. They actually have a really good data set. Vogue's been around since the mid 1800s. They used to be a weekly subscription service, but they'd always talk about fashion and culture. They've since moved to a monthly service, but their database actually has images from every designer, their lookbooks per season. I don't know how far back it goes or how complete it is, but it's kind of an insane amount of data there. It's equally surprising that these images, they may have an article associated with them, but the images aren't labeled at all. It's just, here is this person. It doesn't tell me if they're wearing a jacket, necklaces, or whatever. It's really just just the image, and that's it. There is some kind of need there to go to go through. So I only chose top designer, which is I have 1,400 images, actually 14,000 images, over 235 fashion shows. I picked my top designers based on just an article that I'd read about kind of the most influential fashion designers. Some of these you may recognize, some of these you may not. I didn't know all of them before starting this project, and I'm still not sure I do. But anyway, so here's a pretty good graphic of everybody in my data set. Pre-processing the data was a big chunk of the project. I first used TensorFlow, and I used a pre-trained model. I didn't develop my own model to isolate the models. I used a process called Canny edge detection to remove the remaining background pieces. I used k-means clustering to group colors so that I would have fewer RGB values in the image, so that I could kind of make comparisons. And then after I did clustering, I named the colors. I used the Pythagorean theorem and XKCD's data set to actually name the colors. Naming the colors actually isn't super necessary, I don't think, but it also helps with my sanity because graphing color was kind of an issue, which I'll discuss later. But the reason why I had to use TensorFlow at the beginning, when you look at a fashion image, 60% of the show are not pixels that involve the body. So I had to really kind of narrow in to isolate the clothes. So in doing that, I used this TensorFlow image. I had actually downsized 10%. The images are about 10% of the size. I've blown them up on the screen, which is a little unfortunate. But it increased my processing time by about 50%, which is or decreased my processing time about 50%. So I lose 10 times the data, but only gain half the time. But anyways, what I did was isolate the model. It would pick up a bunch of other items in there, for example, handbag. I would pick the largest image in this picture, and that I would say that is the model. You know, looking through the data, it doesn't look like I got any handbags or crowd people. It looks like it was all models. And then I used a process called canny edge detection, which looks at the different gradients and how they change. It looks at the pixels to the left and the right of it, below and above, and says, okay, where are the edges of this image? And I took the leftmost pixel and the rightmost pixel and then treated that as a mask. So that what I was left with was just the model. I'm still left with a good portion of the model that is skin. I chose not to, there are processes to exclude it, but with different skin tones, you can like exclude skin and then not exclude skin on some other models depending on what their tone is. And also if there's like maybe like a earth tone color shirt, it would also exclude that. So I chose to leave skin in to kind of preserve the data. And since skin is probably going to be present in every image, it'll, you know, kind of normalize out would be my guess. And then I would, after using, you know, k-means clustering, I would get all these clusters of the image. So I'd have 20 kind of individual colors that represent, you know, what's left in the model. Now, even after I reduce those, every image can have a, you know, kind of its own unique colors to it. But if I wanted to compare, I had to actually name the colors. It's a pretty non-trivial task. XKCD did a study where they had over 200,000 participants just like typing in names of colors they saw on an RGB screen. RGB, you know, and depending on what monitor you're using, things can just, whether you're colorblind, things can just look different. They published a text file that includes RGB values and their corresponding color names. Which I chose 152. I chose 152 because the biggest box of Crayola crayons has 152 colors in it. So it just seemed reasonable to me. Anyway, so I mapped, I arbitrarily picked the bag of colors. Surprisingly, with my 14,000 images, only 140 showed up. This is my whole bag of colors. I actually don't know which ones did not come out. I threw the color puke in there as I let that stay as kind of a joke, and it ended up actually showing up a lot. Cause I didn't think it would, but you know, it's there. So mapping the colors, really once I got those color clusters, I thought of you know, the RGB color space as kind of a cube, and really just use the Pythagorean theorem. I had a cluster, I had my bag of colors, I compared it to saw which one was the closest. That color is close enough to cerulean, it is cerulean. Now, once I had that, I could actually look at the frequency of colors in an image. This is actually the entire data set, all 14,000 images, the ratio of pixels that are in there that are this earth tone. Most of them are light gray. It's really kind of boring on the outside, it seems, because those are going to be the most common colors. What's really interesting is kind of what's in the center of our circle. I found a way to address that because that's going to be kind of what you want to focus on. You know, fashion, as we saw from the video, is all about nuance, right? It's all about the little things and the little touches. So, you know, I'll talk about that in a second. Another way to visualize color, this is a similar methodology to kind of group it. Again, the area signifies frequency. This is a tree map, which they often use in like stock portfolios, where they'll, you know, kind of group by a, you'll group by kind of a, yeah, like an industry, thank you. And here I grouped by kind of like a hue. Go ahead.
How much so from the bottom left, how much rate seems like in the bottom left, that's kind of more yours.
Yeah. And actually, so this, I did this two ways. I kind of like attributed, not so much skin tone, but so I actually went through my bag of colors and labeled every color with, this is kind of grayscale. This is kind of skin tone. This is pink, this is purple, this is red. I also did it with hue, which is an actual calculation based on the RGB values. It didn't look as good. But yeah, so those very much could be skin tones, and those were kind of a guess of what could be skin tones, maybe. But I don't really know. And there's not really a good way to tell without like going through like and looking at the clusters and seeing what is labeled skin tone, what isn't. So that's kind of like a guess at what is skin tone, and the proportion's actually about right of like what, if you can imagine like, you know, that bottom left corner being like head, legs, and arms of a picture that you'd see with someone wearing the rest of clothes. So that, you know, I think that was good visualization for exactly what you're saying, is that proportion seems about right. So, but I mean, you could also have, you know, khakis and it'd be that beige color. Mm-hmm. So I actually, my next step, and I thought this was going to be kind of a fool's errand because this was a capstone project. I had to do some modeling to show that I learned something. And so I used both logistic regression and naive Bayes. I found and the reason why I chose naive Bayes to use it was because naive Bayes is commonly used for extracting information about text. And a bag of colors looks a lot like a bag of words, right? So I kind of did both. I did get much better results with logistic regression. It did take about 1,000 times longer to do logistic regression. Naive Bayes was much, much quicker. But a logistic regression performed best, and I could get some more intuition out of there with some coefficients. But this actually turned out to be a really, really good exercise for developing intuition, because what I got with logistic regression, right, and all I'm doing is optimizing with colors. I'll actually get there in a second why it was awesome, but I'll show you some of the results of my logistic regression. I started out predicting designer. In my data frame, I included what season it was and what year it was as well. And I could actually get 80% accuracy for some designers, which is bonkers, right? I've got 25 designers. You know, monkey throwing darts is going to get about 4 or 5% accuracy, and with knowing the year and the season and mostly just color, I could predict one designer's style by 80%, which is impressive. And if you look at and so that's going to be this guy, which is going to be Moschino. And if you look at the confusion matrix, kind of going up the table, they really didn't classify other designers incorrectly. You see a few other designers, a couple other being Calvin Klein. But what's interesting about Calvin Klein, if you look up at these two columns right here, there's going to be the dark purple. Going up and down, you see a lot of misclassification. A lot of other designers look like Calvin Klein, right? So they, so it's you think it's Calvin Klein, but it's not quite, right? But I found Moschino very interesting because they came out. Now, when I took out year and season, I'm just looking at the color palette. I got much worse accuracy. About 20% really was kind of was the average there, and you get a much more misclassification. So year is obviously influential for naming those. But anyways, these are my ugliest graphs, and I'm going to get more to colors and whatnot. But so based on the outcomes of my logistic regression, I could say by designer what is their most defining color based on their highest coefficient for logistic regression. So for every time you see a dark green, that's going to increase the likelihood that brand is Moschino, and that's as we saw from our confusion matrix. That's very enlightening. It's predicts Moschino very well, that dark green. I could also, for every designer, look at their color palettes, right? And this is an intentionally confused, like there's a lot going on in this slide, but every brick you see is a designer, and every line is going to be every line is going to be one of their top coefficients. And what we see is just a very different color palette for each designer. So if I'm deciding which designer I want to model off of, and kind of want, I can look at this color palette and know, these are the colors of this designer. Go ahead.
Is this color over time?
This is without time. This is my entire data set defining color for everybody. I did model without time, and I can show that later. Go ahead. No, they're not significant. For this graph, they're kind of split up a little bit. So yeah, no, order does not mean anything here.
How did you choose these colors?
These colors correspond to the highest coefficients, top 10 highest coefficients from my logistic regression that predicts designer. So the point being, and this is the next slide is kind of what makes me, which is awesome, right? I'm very excited about the next slide. So this is Moschino, who we've talked about before. I said dark green is going to be super predictive of them. Okay, here's their palette. We've got cerulean, dark blue, dark green, dark red. Again, unordered. But what's interesting about this plot is this plot was not based on any model at all. This plot came from TF-IDF. So by treating all the colors, for that designer, and breaking all the images up, these are the main colors. So from feature engineering, I can there's a relationship between what the logistic regression coefficients are and what the TF-IDF image is going to show you. So as a reminder, TF-IDF, if we're not familiar, you take your term frequency divided by your inverse document frequency. And what that's going to do is that's going to make uncommon colors pop. And those uncommon colors that are popping are also going to be really the most defining palettes for that designer. Anyways, I think that's bonkers, right? Because these color palettes are calculated based on a regression looking at everybody. TF-IDF is just feature engineering, no real model otherwise. Go ahead.
So you're in the TF-IDF on the hue number, or like
on the RGB value. Yeah. So the TF-IDF. So it's in my bag of colors. So like dark green is something I call dark green.
Okay.
And so if you think about it like a bag of words, dark green is just a word, and then the TF-IDF value for Moschino is dark green. And also I'm looking at the max TF-IDF value of all Moschino, not like an average or a sum. I'm looking at the highest TF-IDF value.
Did you ever classify based on the TF-IDF features?
I did, yes. And interestingly enough, it made logistic regression perform worse, but naive Bayes iteratively improved, but not to the level of logistic regression. So I used logistic regression as kind of my model because it performed better. Speed was an issue. I would probably stick with naive Bayes, but also this TF-IDF is a good predictor of what those coefficients will be. And since I'm using those to gain insight in general, I think that TF-IDF might be better than both. So I also looked at just kind of another one because I think these graphs are pretty. And Christian Dior, this Christian Dior, again, I said bright blue was the #1 coefficient, shows to be the biggest, and all of these from our TF-IDF correspond to the coefficients found in my logistic regression, which is just occurrence of color, which again, that's super interesting. Also, with this visualization, I can take a snapshot of a fashion show. So if I, think that a fashion show seems really interesting, or there's a lot of buzz around a fashion show, I can take a snapshot of it, break it down into its colors, and say this is what that fashion show looked like without having to flip through the images, which is kind of fun. And actually, the Chanel Resort 2019 got a lot of buzz. In researching, so I decided to just pull that up. And it's got like some pinks and lavender, which is fun. This is kind of an ugly plot. Plotting colors over time was messy. But again, I used TF-IDF here. I was kind of under the suspicion that I may have used too many greens in my bag of colors because they kept popping up in ugly ways. But again, when I did this TF-IDF, they showed up again. So I decided to kind of investigate that a little further to kind of see some evidence. So anyways, I say, look at this plot. So what we're looking at the x-axis here is going to be time based on like quarters, which is about when these fashions are. And then the y-axis is going to be a TF-IDF value. In my Tableau repository, you can actually highlight those and see which show that they were from specifically. So what I see is that you see kind of some Cheyenne from Burberry and Versace. They're using those, but then this Balenciaga green or purple and blue, we see kind of like an increase over time in that. But what was really interesting to me was this like kind of pea green, puke green, grass green color. And all, you know, kind of all of those columns there are actually different designers kind of doing different things. And I looked earlier in the data set, and pea green had never shown up before, right? So Valentina was the first person to use it. We'll look at that in a little bit. But in addition to that kind of inference that I did, I used a cosine similarity. I used the TF-IDF values kind of as rankings, like you would for Netflix or Spotify, for each image, or for each designer, or for each season. Would use a similarity matrix to find out, and a cosine similarity matrix to see what the cosine differences were. The shortest distance were very much alike. And when I did this, I did it on everybody. I picked I could see which images are most like all of them. So when I did that, I said this image on the left, which is from Chanel, 2015. That image is most like every other image in my data set. It is closest to everything. And then based on that image, I said, okay, well, what else is this image like, right? What else am I? So I picked the top four, you can kind of see they're not exactly the same, but you see this kind of pattern of like this kind of gray, white thing going on, right? They're very, the consistency of color in each of these is pretty similar, which I found surprising. But really cool, right? You know, if I've got a fashion worried about kind of copywriting, I can use something like this to determine what's close. One thing that I do notice about this, because I didn't handle skin very well, my algorithm is kind of racist. And part of the reason why all these people are alike is because their skin tones are all about the same. What I also saw, and something that was very, very different, which was this pea green, I found this Valentino, which I said was the first time pea green showed up. Actually, because it's such a different color relative to everything else, I actually had to go through like 20 images to find ones that actually contained that green color, because most of the other images they had the same skin tone and hair color. So anyways, that's something that I think we can address earlier. But in those top 20 images, by the way, in my whole data set, there were only 45 images that contained pea green. So the first 20 images, I think that's it works pretty well. But I found all these other colors from it showing pea green. I've gotten some comments on my shirt today, which I had. This shirt's been in my closet for a while. Dave Yerington, if you're watching this, I'll just take a picture of the shirt. I'm not going to share my video, but I'll send that to you. I picked a kind of a boring white shirt with a tie to wear today. And then I was looking in my closet after doing this slide and saw that this, two-year-old shirt was probably, has some influence by this Valentino show, because it's got, a bunch of colors of pea green in it, which, kind of blew my mind a little bit as I was fishing through my closet this morning. So selected from a pile of stuff, man. So next steps, I'd like to probably train a model with TensorFlow to identify clothing. I spent a long time kind of working up to this on my data set, but just need to get to an answer, so I abandoned it, used the pre-trained data set. But I think identifying clothing is a really good way to solve the skin problem, basically. So you can identify clothing, identify parts that are skin, and kind of go from there. But that's going to take a lot of labeling time, I think. But we'll get there. I'd also like to streamline my data pipeline. I essentially, my data set, I build it iteratively for a proof of concept. All of these images are stored on my hard drive. And then all of the smaller images from TensorFlow are stored on my hard drive. All the canny images are stored on my hard drive. It would be much better to streamline that pipeline so that I can, see an image, process it, delete it, move on, and then all I'm left with is a much smaller data frame. And that way I can effectively also keep all my information on the cloud, run things iteratively. I'd also like to include more images. Part of the reason why my time series analysis was made more difficult was because of 3 years is not a long time in fashion. You think it would be, but for identifying trends, seeing something like pea green pop up, I'd like to see a lot more of that stuff. And maybe see pea green pop up more over time. And that's very possible with the Vogue data set. It seems to be very complete, at least to the year back to the year 2000. And so, kind of iteratively increasing that, I think would be very interesting. So I think that is it for my presentation.
I was going to say too, it's like they say fashion always comes back. So
Yeah.
you can probably go decades back and see this is what happened one decade, this is what happened the next, right? There's some correlation there.
Yeah. So, and then, Tableau is always fun. We can, look at season by designer. This is a great filter. So this is like, if I look at everything, this is the TF IDF. When I first see this, I think that, maybe I oversampled in green in my bag of colors. But what I really think is that there's actually a trend there that we're seeing, and it's just popping its ugly head out. And then, but this is kind of, where we can like focus on and pick a designer and say, hey, this show, spring 2015 menswear, this is what came out of that. All kinds of stuff. Tableau's fun.
Did you, when you started off, you were looking at scraping Nordstrom's website to identify specific articles of clothing. You moved into this color thing, and you're working it a lot. But did you start off thinking about using what are essentially NLP processes for identifying colors, or is that something that evolved over?
No, it evolved over time, and my process actually didn't start out involving a hypothesis. I just thought fashion was kind of a unique thing that I wanted to try, and I just wanted to see what I could learn from it. So it definitely evolved over time. I had some ideas, and they changed quite a bit as time went on. Scraping scraping a company's website, like Nordstrom or Zappos, was something I kind of focused on for a while, and found it, one, to be difficult, and two, it's things that I think other people have done a lot of before. It just wasn't as interesting either. So Vogue had a really easy data set. So when it came time to really crush some stuff, Vogue was the easiest way to kind of go about it. I do have web scraping algorithms from Nordstrom and stuff. And I think an interesting application that we could do with this cosine similarity is to take a picture, maybe of a person, map it to a designer, and then maybe map that to some clothes that you could buy, or vice versa. There's a lot of cool things you can do with that, but I do not have a data set where I've got kind of clothes involved. But I think that's a really cool application.
You talk about a cheaper but similar version. Style comes out. I'll give you some other styles similar already.
Yeah, so let's say I have a store, right? And it's so I would pick that store and I'd say this style, these colors are similar to these items in my store.
Yeah.
Have you thought about predicting what colors are going to be fashionable next quarter?
Yeah, so that would be interesting. No, I have not done anything, but that would be interesting. I don't know. I don't think my data is long enough yet at this point. I can break it up. This graph that we saw, right? I can break that up. Right now it's quarter by date. You know, you can break it up by month and get a lot more, and kind of see these differences in colors. So I think, you know, kind of like how big that time window is. It's a complicated problem, and I'd be interested. Then it would be interesting, but I think I need a much wider window to be able to play with that effectively. Because right now I'm pretty sure the answer is puke green, but you know, that might be different for different periods of time. Thank you. All right, and I'm going to stop recording.